Okay, so let's begin. So first of all, I want to thank everybody for joining today. The webinar today with ATEM and some of our special guests is Station's Guide to Next Gen TV, Reimagining the Future of TV. Our panel today, on the panel today, we have Luc Fay, who is the Technology Group 3 Chairman of ATSC. So Vang is the Vice President of Advanced Technology at NAB. Mikkel Relay is the Vice President of Innovation at ATEM, and myself. And the goals for today's meeting, I want to give each of the panelists, first of all, thank you very much for joining, give you each a little 5 minutes to introduce yourselves and the work you're doing with your companies. We will have a question and answer session at the end of this session, so anybody who has questions, please submit them in the chat panel. And there will be a couple of polls during the event just to get your feedback as we go through the things. So with that, I want to give Luc some time to give a brief introduction to ATSC and what you guys are working on, what the goals are for that organization, and how that applies to Next Gen TV. Luc.
Sure. So I put in a few slides there. Oh, great, thanks. So to start off with what the ATSC does, our mission is to create and foster implementation of voluntary standards and recommended practices to advance the terrestrial digital television broadcasting and facilitate interoperability with other media. That's been the mission, I think, ever since we started back in 1983. So if we go to the next slide, there we go. We did start in 1983. We were founded by CEA, the IEEE, NAB, NCTA, and SMPTE. Our focus is on the terrestrial television broadcasting. We are an open due process organization. We do have around 125 member organizations. So those organizations are spread across various industry sectors, as you saw there. To start off with why are we here today, I came up with a few questions. First, what is ATSC 1.0? Basically, that's the HDTV that we have today. For any ATSC adopted country, it's the digital television that you have in your houses today. Then there's a lot of buzz going around about ATSC 3.0, but the question immediately comes up, what happened to 2.0? And basically that work was to integrate the MPEG-2 transport with online services. But the momentum of ATSC 3.0 overtook that rollout. And so what we have today basically is ATSC 3.0, which is not backwards compatible with ATSC 1. Now, given that it is not backwards compatible, why would anyone want to do that? So there has to be a lot of compelling reasons for broadcasters to use ATSC 3.0. And ATSC took this on some 10 years ago. We started asking the tough questions. And what you see here is broadcaster desire to compete with online content, to keep up to date with evolving technology, personalized services, secure broadcast, and integrate with the broadband services are just a few of the reasons why broadcasters would want to go with ATSC 3.0. I'll note that it is a voluntary standard. Broadcasters do not have to choose it. However, there are many compelling reasons to go there, like you see listed here. I think the next slide gets into the organization. Yeah. So at the top, we have ATSC members. We have a board of directors, which kind of guides everything. We have three main teams that report to the board of directors. First is the implementation teams, and we have two of them, the Advanced Emergency Alert and Conformance Testing. Next, we have a technology group, which actually develops the standards, and we have specialized groups. Each one is listed there with a number, S31 down to S39 and S41 and S42. You can see what they're responsible for in their titles there. And the last team reporting to the board of directors is a planning team. And this is how the ATSC continues to evolve in the future. We want to keep our eyes open, look always to the horizon. And we have 5 planning teams in play right now. First one is PT4. The first 3 planning teams have already stopped. They were basically looking at the startup of ATSC 3.0. Since that's already going, we've moved on. But we're looking to future technology, some automotive use cases, worldwide promotion, a service roadmap of where broadcasters want to go, and core network technologies. So next slide, if we zoom in on technology group 3, you can see the layout structure here. We also have the specialist groups listed down below. That's all a flat line structure there, where each specialist group has its own responsibility. And in addition to the TG3, we have our own ad hocs, which are specialized groups of experts that can gather together to complete a task and then go away. In all of our work, if you go to the next slide, it won't take too much time. Basically, we have how our work is assigned and approved. We have the board that develops requirements, or the planning teams, or we have other interested parties that come together, and they all report to the board, and then the board would approve a project and then assign it to the technology group. And the last slide, I believe, within the technology group, there we go. We have a working draft, which is started with a contribution, and the committee works on that in a de jure process there, and via consensus, the committee recommends work to a TG3, which then would approve it for ballot. But then after a working draft, we go through a candidate standard or a proposed standard, which can get exercised and kick the tires, as it were, to try out the technology. And if everything looks great, we have another ballot there for the membership to make it a full standard. So that's kind of the process ATSC has, and that's what we've gone through the last couple of years to develop ATSC 3.
Great. Thank you very much for that, Luke. So I'd like to turn it over to you and let you give a brief introduction on NAB and the work that's going on there.
Sounds good. Yeah, so there's a lot of new things happening at NAB. Mainly, we're moving to a new building. Here's a picture of the NAB, and a little bit of background here. We are a trade association, and we obviously do provide a lot of services that further the interest of our members, and we have members from on the radio as well as the television side. As you probably, when you think of NAB, you probably think of the NAB show and the NAB association. But if you look at this slide, we have a couple of organizations within the company that really that sort of does some really good work. We got our government relation, we have a radio group, we have a television group, and we obviously also have a technology group, which I happen to be part of. Next slide. So we are moving. NAB as 1771 was our old home, and as you can see here, this is under construction by the new owner. As one of my colleagues, Lynn Claudy, pointed out, even at this, these days, even our buildings wearing a mask. So anyway, next slide. So this is our new home. We were expected to have already moved here, but because of the sheltering in place and etc., we have not been to our new place. As a matter of fact, I've only been to this building one time, and it was under construction. So along with many of my colleagues, we are all really looking forward to moving to our new home, hopefully soon here. Next slide. So some of the major events, that you probably heard, we obviously have the NAB show the ones that usually take place in Las Vegas, which didn't happen this year. We also have the show in New York, and we have our radio show. And this year, because of the circumstances that we are in, we're trying to innovate, and we have this new event called the NAB Show Express, which will take place next week. And you can go to nabshowexpress.com to register. I believe this is the first time that we have done an online show like this, and we're really looking forward to it. The program looks really good, so we hope to see many, if not all of you there. Next slide. Okay, go ahead. So one of the things that NAB has been consistent at in terms of ATSC 3.0 is that our goal in terms of supporting ATSC 3 is we really want to help move forward the ecosystem and really help with the deployment of ATSC 3.0. So to that end, what we've done in the past couple of years is when ATSC the standards started to mature, there weren't any receivers out there. So we went ahead and built a proof of concept. All of these are proof of concepts, all the things I'm describing here. We went ahead and built an ATSC 3.0. Basically, it's a gateway, a set-top box. In the next slide. And in addition to that, we also went ahead and built a runtime environment in ATSC 3. One of the really interesting part of ATSC 3 is the fact that it has a middleware. It basically has software capabilities. So we also went ahead and built a complete software framework for the runtime environment. And the reason we're doing this is so that we can start to do prototype. And so if you move to the next slide, you'll see that what we've done is that we started to one of the most important thing to talk about technology with people, particular folks who are not technical, is you got to show them something. And what we've done is that we built the gateway, and we built the software environment, and then we started building some proof of concept services. And these are example of services where we can achieve a couple of things. One is show our memberships and show business people what you can do with the platform. At the same time, by going through this exercise, we help verify some of the things in the specification. We run across things that maybe there are errors or there are issues with the spec. So it is a way, really, at the end of the day, all of these things are a way for us to really help move the standards along and try to move the whole ATSC 3 ecosystem forward. I think that was my last slide.
Great.
Right.
Yep, that was it. Thank you very much for your introduction. So I'm going to hand it over to Mikkel briefly for a quick introduction on some of the work you're doing with ATEM. Mikkel, you're on mute.
Yes, it's back.
Okay.
So I'm in charge of the innovation at ATEM, and I have been involved also since a while in ATSC. So that's been almost 3 to 4 years that I have been involved in the standardization activities, and I would like also to thank my partners here for this webinar. So involved with LoopFi for the TG3, but also in some of the PlugFest that NAB and Pearl was organizing. So I met also quite a few for some of the PlugFest that they were organizing, and I was happy to be there. So except than the standardization, I am doing other stuff, but mainly I was involved, and I'm still involved in the early deployment of the ATSC 3.0.
Okay, thank you very much. All right, gentlemen, again, thank you very much for joining today. We've got a number of questions here, and I want to just put them up on the screen and talk to you about various different aspects. So perhaps we can start with you, Luke. I mean, ATSC 3 is a reinvention of broadcast standards. In taking it, we've combined sort of OTA, but also added OTT, internet-based transmissions. Can you talk about some of this in terms of the ideas and thoughts that went into building this and some of the convergence around this?
All right, thanks. It was thought on about 10 years ago when we first gathered together. The broadcasters were looking at what they had, which is basically an MPEG-2 transport with a locked payload size. And they were realizing that the MPEG-2 codec itself was getting old. There were services online that were using more efficient codecs, and they had access for personalization. And back in the day, they were looking at Netflix and Hulu and some other online providers, and realizing is that something we need to compete with, yes or no? It was a lot of questions. Since then, it's been very evident that online services is very popular, and broadcasters need to stay relevant with their consumer base. So back in the day, it was a pretty good idea for the broadcasters to say, look, we need to venture out. We need the ability to compete with Amazon Prime and these other content providers. And in order to do that, we have to either invent something that works with the internet or just flat out uses the internet itself. And it's much easier to go along with the internet than it is to compete with it. So the early decision was to basically align with the internet. Let's engage with that service there and its capabilities and all the service offerings that it would provide. So one of the concerns that a broadcaster might have is that, okay, if you engage with the internet, how do you make your service local to your market? And so what ATSC3 did is make the signaling be broadcast over the air. And once a device would receive the signal off air, it could feed back with the internet back to a broadcaster and start to engage that way. So with this concept of broadcast, which is one-to-many, ATSC3 now has the ability to get personalized service with customers. So it's allowing a broadcaster to get hyper-local information to them. It allows them to have in-depth stories or offer more content, if that content is 4K, for example, or high dynamic range or high frame rate or whatnot. Engaging with the internet allows a broadcaster to signal his basic service, let's say HDTV, and say, okay, for more in-depth stories, you can click here with an interactive app. You can see all the extra information or extra content I have, or further enhanced content if it's 4K, if you have that ability on a device, or just all these different options that the internet provides. So it's a way for broadcasters to get more in tune with their customers. And the convergence was seen early on that it was not really an option, it was really essential for them to keep going on.
Do you see, and maybe so you can answer this one, but do you see sort of new applications and new areas where this gives access to different markets?
Yeah, so I think Luke covered quite a bit of it. I mean, it is pretty wide in terms of the opportunities that this enable for broadcasters. The way I look at this is that with the OTT side, it brings in some additional tools that broadcasters did not really have it before. I mean, broadcasters today, we have sort of the traditional television, the OTA side, and then we do have the digital side, but they work they were kind of, you know, they're kind of, I would say, siloed in probably not the best choice of word, but they kind of do their own thing. I think that with this convergence, at least for me, it really means that broadcasters now have the ability to really sort of converge those two groups together. So some of the examples that we have demonstrated for many of our proof of concept is, for example, something as simple as weather, like a weather application. In the past, you would have to go, you either get your weather during prime time and then it goes away, or you would go to the local TV station and get it there. But with this convergence, now we can sort of combine the two together. You know, we can have an app that's running on the TV set, and it can be pulling some of the data and the information that maybe the digital folks have already developed and put together for IP devices. We can bring that right onto the TV set. So yes, it does. The second thing I will point out is that with the OTT side, it does one thing that we currently don't have today in OTA, and that is it sort of gives us a return channel. So allows us to pull some information back from the receiver side.
Okay. All right, I'm going to get more into the technical side of this now, and I wanted to pull Mikkel into the conversation. Can you give us an indication of some of the technologies that we've added into this standard? And really a question is why some of those technologies are getting pulled in.
So we just have to come back to the initial presentation of Luke. So he was saying that ATSC 3.0 doesn't reuse anything from ATSC 1.0. That's particularly true. So they look at the technology that the people were keen to hear about and looking at the technology that was available. So they started by the codec. So the codec that was available at this time was HEVC, that was giving 4 times better compression than the previous one that they were using in ATSC 1.0, that is MPEG-2. And then they were also looking at next generation audio, so they can have a single audience and select the language on top of it. That can be, so in case of the US, that can be English and Spanish, that are the most, let's say, the most spoken language. They also look at the fact that you have the ability to do, so it's based on internet protocol. So they also select an internet protocol. So they use MPEG-Dash, that was the most used standard at this time. That was also coming from MPEG. And they also look at a standard from MPEG, that is MMT, MPEG Media Transport. So they decided to go for the two and to go also for the 2NGN technology as a base. So everything is really new in terms of technology and not backward compatible with the past. And then you have the ability to do a lot of things on the receiver side, because you have a way to connect it to the internet, so you can have some targeted advertisement that can be done at the receiver side, and you also have the ability to reuse DRM from MPEG-Dash, so Widevine can be used as a DRM and protect your signal.
Okay. So anything to add on that in terms of some of the things you wanted to include in the standard?
No, I think that's good. I think that we pretty much cover, or I think at the end of the day, what we're looking for is a platform that really would enable broadcasters to innovate into the future. And I think ATSC 3 has adopted all the right technology. And I think now it's really about getting out there, get it deployed, and so that we can start to experiment with it.
Yep. Okay. All right, I'm going to launch a poll to the audience now. I think we wanted to understand what people see as the most compelling feature within the ATSC standard. I'll give people a little bit of time to answer this. Okay, a few more seconds. Anybody who's not voted yet? All right. So that's interesting that we get quite a spread of the different features, but OTA and OTT transmission in parallel seems to be the largest share of the vote. We talked about the IP-based standard, and also dynamic ad insertion are up there as well. Okay, so let's, as you were talking about, the getting this out in the real world and working, let's move this on. And so maybe you can talk a little bit more about some of the efforts that have been going on in terms of interoperability in the field.
Yeah, so I think we had a couple of slides on that. As I noted earlier, what our goal is really to try to help push the ecosystem forward. So we've been working for a lot of these projects, in particular for the interoperability events and our test station that we had in Cleveland. That's since been packed up now. We're trying to move some of that equipment to our new building. But we started that about a couple of years ago, and in collaboration with CTA. And that is to get a test station in the air, and so that we can go and do some testing, some measurements, and also we generated test streams. And those test streams could be were made available to partners who need who need them for testing purpose. And so a couple of the pictures here is from from Cleveland. In the next slide. In addition to that, what we also have been doing, again, in collaboration with CTA, is we've been going to various stations and what we call interoperability events. And basically what those are is that we go in there with sort of a game plan of some of the things that we want to be able to verify. And then we bring in our CE partners and whoever else who want to bring in equipment to test or to verify. And it basically is kind of like the Plug Fest. We put things on the air, we send it down, and then we go to each receiver and see if it worked or not. I mean, it may sound cruel, but basically at the beginning of any technology, that's basically how it is, And then for things that don't work, we document it and we fix it, and then we try to get the next time. And the idea is to keep doing that and keep making progress when you go from one interops to the next. And so, as you can see, some photos here. We have some, it was a very good collaborative environment where everyone worked with everybody else. Naturally, there's a lot of competitive. This is a very competitive area, but when we go into these interops, I think the thing that really surprised me, or maybe it shouldn't surprise me, is the fact that we all collaborated and we worked with each other. We had Samsung working with Sony working with LG, and it was all about trying to move everyone forward, one step forward. And so I believe that these interops have been very helpful, and we're going to continue to do more of these interops. Of course, we got help from all the back-end equipment too, and not to mention, we had Mikhail, Tam, and all the other folks were there as well. But I know that given the situation that we're in right now with the coronavirus, it's going to be challenging for us to continue to do this type of interops, but we are working on ways to do remote interops, and so stay tuned for that. But we plan to continue to do some of this stuff in order to keep helping our partners and trying to keep pushing the ATSC3 ecosystem forward.
Okay, interesting. So as well as the interops, I also want to talk about a little bit of the transition and what's going on there. And again, maybe so you can give us a quick introduction on that side of things.
Well, so I think that I think the folks, the Pro has done a really good job at this, and I think that we've seen sort of the plan in terms of the lighthouse and all of the things that were announced at I believe the last time we saw a whole bunch of this stuff was at the CES show. That was the last major show that we all had before all of this happened, and so I think we're all moving forward. I know.
Yeah.
I understand that it is inevitable that this virus has really, has impacted everyone in every way. But I think that as an industry, we are continuing to move forward towards 3.0.
Okay. Luke, any comments from your side on the transition plans?
Yeah, so I think this year is the make or break year for ATSC 3.0. And there's a site that the FCC has where you can see the applications from broadcasters when they want to choose to go to ATSC 3.0. I don't have that readily available right now, but it's out there. Yeah, there's a good graphic.
Yep.
Basically, we are seeing that there are many broadcasters signing up for this. And they see all the compelling reasons to go there for the interoperability, the ability to compete with online services, to have a more robust transmission, have the ability to address mobile devices, stationary devices, experimental devices at the exact same time is so compelling. It allows them to advance their technology as it moves forward and not be locked into one thing for 10 years, for example. So we're seeing a lot of uptake on this. It's very exciting. One of the things that broadcasters are facing is the pressure, basically from the wireless networks. They are still now going through a 600 megahertz band plan restructure, where all channels above 37, I think, are being reallocated to wireless carriers. And so the existing broadcasters are having to move. And what this points to is that their spectrum is becoming more and more valuable, I think. And this move to the digital dividend is placing broadcasters in the prime area for use of their spectrum. So there's a lot of interest in it, and one of the features that they see is ability to address their customers wherever they're going, and not just the homes. I mean, I remember back when, well, I'm not going to say how many years ago, back when I was growing up, people would go home to watch TV, and it's just not the case anymore. People expect to see their content from broadcasters right now. So a lot of broadcasters have their digital side of the business, their websites. Please go here, download their app for local information. And especially now, with the COVID-19 as an example, broadcasters being an information utility of the market, basically being the reliable source for the public, is continuing to show that they are desired and have a vital role in today's world to have the correct information out there. And the more people they get, the more they're more applicable. So ATSC 3.0 being able to address more devices and more people across their market just makes it more compelling for them to go here. So this map is a great graphic. It shows, it's vitally needed, and the broadcasters see the light.
Okay. Mikkel, what about your view on the transition? How are you seeing things move?
The challenge of the transition, at least one that I know is on the video compression, is that when you switch off ATSC 1.2 channel and you want to replace it by ATSC 3.2 channel, then you have to reallocate this particular channel on 1.2. So you have to do more compression, more video compression. So it has to be a good MPEG-2 encoder that is doing that for ATSC 3.2. And so at the same time, for the ATSC 3.0, you will benefit from from the best video quality that you can have. So because of HEVC, you will have a better video quality for those that will receive ATSC 3.0 channel. So most of the challenge is on the video compression itself. If we don't want to sacrifice those that are still on ATSC 1.0, we have to implement new algorithm for MPEG 2 and not to rely on the old MPEG 2. So we still have to do some research. And the fact that everything is moving to software, then you can easily change from MPEG 2 to HEVC if the channel is going to HEVC in the end.
Okay. So obviously in the US, the markets are starting to grow and starting to move forward. But I mean, ATSC has been around, ATSC 3 has been around now for several years. Luke, maybe you want to talk a little bit about some of the things we've seen in the market in terms of what have we learned from other markets like Korea?
Yeah, right. First off, yes, Korea was the first one to launch with ATSC 3.0 back in 2017. They had a big drive from the government to make it available to their public for the Olympics. And so, first off, thank you to all the Korean broadcasters out there who actually started buying equipment and having the equipment vendors implement the ATSC 3.0. It really drove home where things needed to be fixed in the standard itself. Everything looks great on paper and in thought, but then when you try to implement things, you find, oh, well, there's this one little step you need to fix and whatnot. So it is the 3rd anniversary. They've been up for quite some time, and thank you to them for starting it. Basically, the spec gaps were filled in. But one of the things that we also learned from that initial launch is what broadcasters really intend to do with the standard. And one of the things we found out is mobile services. That was very key. And the ability for ATSC 3 to address a variety of devices simultaneously is extremely compelling to go there. They don't have to simulcast content if they don't want to. There's technology of SHVC, the scalable HEVC video codec there, and that allows for them to target mobile devices with a base layer and then provide metadata for stationary devices to fill in the picture for a higher quality 4K type of picture, if you will. So it showed a lot of key use cases, and also one of the key use cases that was found in Korea was interactivity. So ability to vote or whatnot was also interesting to see. And it allowed us to improve the standard for what we see now in the US. As a side note, I would say that Korea has not stood by idle. They also have set up an RF testing lab in the Jeju Island, the southern part of Korea there. And they're still testing on that island with the optional technologies like MIMO and other aspects of it. So they continue to be pushing the edges of ATSC 3 and finding out the best things that there are about it. As far as expanding into regional other areas, we continue to get interest, the ATSC does, regarding ATSC 3, mainly from our neighbors in Canada and also Mexico. The ATSC has a planning team 6. I might have mentioned that earlier. It's on worldwide promotion. And we have participants there across the globe. And India is another country that is also participating. So this is not an American standard. It's the Advanced Television Systems Committee, and it applies to anybody who chooses to adopt it. And so there's many countries who have interest. It's a very efficient operation of the spectrum and allows integration with the internet. So there's a lot of compelling reasons to go there. And I think India has a slant to look at this with a combination of 5G. But I think that's another topic we'll touch on in a little bit later, Dave.
All right. Okay. I'm going to move on since we're starting to get out of time. I got one more poll I want to just ask people. And this is around what do you see as the biggest hurdle in ATSC rollout? I'll give you a little bit of time to answer there. All right. Any more quickly? All right, let's end it there. So, results that we have on that one, no government mandate. People viewed as the biggest cost, not far behind it. We have the cost of infrastructure as well being a hurdle on this. All right, thank you. So next topic. So I want to talk about some of the new things that the standard brings. One of the main ones that people have talked about has been dynamic ad insertion. So on this topic, it's been viewed as one of the major drivers for this, but do you think it's something that people are going to take?
Did we lose Dave?
I should still be here.
Oh, there you
Can you hear me now?
Yes, we can hear you now.
All right, I don't know what happened there. So question for you, really, this monetization and dynamic ad insertion, is this something that you see as growing into the market, or is this something that's going to be a driver from day one in the ATSC3 space?
Yeah, that's a really good question. I do think that it is something that, in terms of the ability to do some targeting, like zone targeting, etc., it is something new. I mean, it is something that broadcasters, at least in sort of that traditional one-to-many, we have not had. So this is something that I think will be really important for broadcasters to take advantage of. How they choose to do that, that's really up to the, I would say that's up to each of the broadcasters, but the technology is there. And I do also think that early on, what we got to do is figure out what is the most efficient way to do some of these things. We've done some experimentations and some proof of concept around using X-Links, for example. But I think that we still have a little bit of work to do in terms of the complete end-to-end portion of it. And we know that the receivers can actually process the X-Links and be able to do some of the replacement on the receiver side. But I think we still need a little bit of work on the complete end-to-end. And there's opportunity, for example, for some of this stuff to actually come via the OTT side, and we can also use the NRT to sort of pre-cache some of the ads in advance to provide a much better seamless experience for the viewer. So I think there are still some work, a little bit more work that we need to do in terms of making it work seamlessly in the end. But I think all the hooks are there, the technology is there.
Okay. Mikkel or Luke, any thoughts on this topic?
Yes, so something that I was not saying at the very beginning, and so I believe that ATSC is really user-centric in the way that you can do targeted ad advertisements. So depending on your habits, on what you are seeing, then you're looking at the TV, then you will have some dedicated advertisement that can pop up, like what you have on your on internet. It's also, you have to remind also people that what we are having on the TV is not only a TV now, it's a web browser, so it's connected to internet all the time. And this is how you can have some pop-ups or things that are coming from internet. So there are a lot of ways of doing some money out of this particular use case of targeted advertisement. And it's not the broadcaster that is like in ATSC 102, everything was coming from the broadcaster, everything was fixed in the image. Here you have a lot of more that you can do, and you can bring that to the end user.
Yeah, I agree with Mikhail that, you know, people are used to getting information from PC now, or their phones. And when they go to a TV, it's just another screen to them. It might be a larger screen, but they still expect, you know, if I wanted to browse something for more information on a player of a football game or something, why can I not do that on the TV? They can just look at the phone and have the ability. So this ability for broadcasters to provide access to information like that with a broadcaster app or any kind of way to take their one-to-many broadcast and make it personalized, one-to-one, is really compelling and useful, I think. So, of course, the user would have to opt in to use the service. But once there, you know, they can browse, just like Mikhail was saying, and get information that they want. I mean, it's too often the case where broadcasters deliver a generic message, but then everyone is kind of curious, well, how does that apply to me? And so the ability for them to look on a map and say, okay, I'm located here, and this incident is 2 miles away. Do I need to do anything? That's really good information for them. So the ability to reach out and make contact with their customers is worth a lot, I think.
Okay, great. I want to look a little bit into the future. ATSC is, I believe, a sort of organic standard in that it's growing. I think you mentioned that before, Luke. So, Mikhail, maybe you can talk a little bit about some of the other technologies that we're looking at going forward.
Yeah, there are two technologies that are arriving at MPEG on the video compression side that are VVC, that will be H.266 in July. That should be in H.266 in July. And there is another one that is essential video coding, or MPEG-5, that will arrive also soon in July as well. So those two core technologies will bring up to twice less bitrate than HEVC. So looking at the bandwidth will still be the same in the end, or not a lot more, even if we can do a bit more on the modulation side, but not that much. It means that we can, with this particular codec, still bring a factor of 2, or either to increase the resolution or to increase the number of services that the end user will have. So that's opportunity that they are looking at, to see whether they need to integrate another codec in their future inside ATSC. So that's the one I foresee, and there is also the combination with with internet, and 5G is coming. So so that's also something that ATSC is looking at, the convergence of the two. One for the broadcast, so you can have the one-to-many and receive a sport event to a large number of houses, and at the same time you can still receive additional services from the broadband, like 5G. So you are still connected even if you are in a car, for instance. So you can still receive the broadcast and then have some additional so the return channel that Sue was mentioning before with the 5G, if you want to have it. So that's the two main technology that I foresee, and that can be a good combination with ATSC 3.2.
Okay. Luke, anything from the ATSC side that you guys are already working on that you can share here?
Right. So we have another planning team of future technologies. It's the PT4. Those video codecs that Mikhail was mentioning were presented to the committee there, and very interesting. I'm not saying anything about thresholds. Are the new codecs 50% more efficient than HEVC? Are they even more than that? Is it compelling to go there or not? A lot of these planning teams just gather information and say, okay, here's the options of where the industry is going. And they present that to the board, and then the board can decide the next step. But in addition to video, there is the next generation audio. Currently, ATSC3 specifies two options. There's the MPEG-H audio, and then there's AC4 from Dolby. One of the compelling technologies of that audio is the object-based audio. So it's the ability to place an audio object like a bee flying around a room, and the audio itself would be the bee itself, the wings flapping. That's the audio itself, and that object can be placed in a three-dimensional space, and then the codecs can actually render that audio around a room more efficiently itself. So one of the things that come up, at least for TV, is dialogue. And dialogue, specifically dialogue enhancement, has become key. A lot of TVs in the public are at bars, airports, a lot of public spaces and whatnot. And it's been my experience that the audio has been off or very low because either it's too noisy, the people want to carry on their conversations or whatnot. So either the closed captioning is on or something else. But this dialogue enhancement is really compelling. Once you hear it, it's amazing. And it's the ability to hear speakers over background noise is really, really good. So that's one of the things that is trying to be exploited for ATSC3. As far as what's beyond AC4, that's a good question. And I think the ATSC remains open to accept any contribution from anybody to show the next step of where the industry might go. So the ATSC is always looking for the next thing.
Yeah, I think you mentioned before about 5G in India. Do you want to expand a little bit on some of those topics?
Right. So as we've explained here, the ATSC3 is an IP backbone, and so is 5G. 5G is promising everything to everybody, including the kitchen sink, if you believe it or not. And it's one of those things where 5G has the ability to do multicast. I think they call it FE EMBMS. There might be some future extension on that. Mikhail can correct me. But basically, it's the one-to-many option of it. And one of the questions that's come up is, why would we choose ATSC 3.0 over 5G? And for a broadcaster itself, the whole essence of a broadcast is one-to-many. And 5G is unicast, it's one-to-one. So some use cases you would like a one-to-one feedback. People have a selections or whatnot of a vote or polling or whatnot. You need that one-to-one as an example of a return channel. But when you look at the use cases of content, a lot of the content being viewed is the same. Even in a certain small cell of a market, like for a 5G small cell, you can have 2 or 3 people watching the exact same content. And when that's the case, one-to-many starts to make sense. And ATSC3 with its OFDM and high QAM modulations and LDPC FEC rate, FEC, makes it very efficient, even more efficient than the 5G codec, sorry, 5G modcodes to deliver data. So there's use cases to apply both, and what we're trying to look at is to combine 5G with ATSC3. There's no competition we're not trying to outpace or beat 5G. That's not true. We're trying to work alongside it. And I think one of the main compelling things we're looking for is for broadcasters to have control over their stations, and maybe not one station, but many stations. And so the ability to put control in the cloud is very compelling. The days of broadcasters buying a box for a function being, here's my video encoder, here's my dash packaging, here's my route encapsulator, here's my scheduler, here's my exciter and whatnot. And there's separate hardware boxes for each function. That's quickly going away. Everyone's going to the cloud now to have that service be updated really quick. And that ability to put things virtual allows technology to advance a lot quicker for broadcasters. So I think going to integrating with 5G and going to the internet and the cloud-based service is really what's on our future around here.
Okay, Mikkel, also, any trends that you guys see? We got a couple of minutes left, so I don't want to take too much time on this, but final thoughts.
Well, certainly certainly for us, one of the things that's really exciting about 3.0 is the fact that we can use applications. I think having great audio and in addition having great audio and great video, those are great. But it will be the first time that we have the ability to actually interact with, provide something that we can engage the viewers via an application. And so that application environment, we think it's going to be really important.
Mikkel?
I think the convergence into OTT and OTA is also something that is appealing in this particular technology. In this particular case, you can see some sport events with the broadcast, and you are sure to see them, and you can combine with the convergence of the OTT because you are using exactly the same format to enhance by targeted advertisement, by the HDR or something, or the NGA that can also come from the OTT, that can be exotic language like French in the US, so that you can have it over internet instead of over the broadcast. But yes,
Okay.
it's the EB is also looking at similar technology today, so that's
Okay. So just wanted to briefly touch on questions right at the end. We have very little time left, but we had one interesting question talked about the indoor reception of ATSC3 versus ATSC1. There's a lot more capabilities in ATSC3 over ATSC1 for this. Will broadcasters use some of these flexibilities to improve the indoor reception, or do you think people are still going to rely very much on outdoor antennas, rooftop antennas, and things like that?
I can take a quick crack at that. I think ATSC3 has the ability for mobile service. And what that means is operating at SNR points of like 3 to 5 dB. The bit rates can be just around 1 to 2 megabits per second. But the ability to operate in the same region as LTE or 5G for robustness is key to indoor reception. And it also allows for graceful degradation. If a broadcaster is sending out 2 services, one for mobile, one for stationary, those customers who have good received power or enough SNR, they have the ability to get a fully developed picture, whether that be HD or not. And if for those customers that do not, indoor reception, they're walking around in a lot of metallized buildings, they can still get an SD picture, if you will, with audio. So I think deep indoor reception with an antenna that's basically the size of a cell phone or no antenna, that you can see, is a compelling use case, and I know the broadcasters are thinking about it because the ability to reach out to the mobile market is key.
Okay, thank you for that. I'm gonna finish on that note. I think I want to thank our presenters today, Luke, representing ATSC and also Sony, So for your contribution from the NAB, Mikkel, obviously with the TEM. I also want to thank Luke for stepping in at last minute since Madeline was unable to attend this week. Pearl TV have helped us out a great deal over the last several months with rollout of this, and they're a key part of that. And I also wanted to highlight, if people wanted any more information on the ATEM product line, they can go to one of our partners listed below. Gentlemen, thank you very much for your time today. Very much appreciate it, and appreciate everybody attending.
Thank you.
Thank you.